Now that we know how to determine if tables are actually probability distributions, let's actually do some calculations with them. So we're going to focus on the mean, the variance, and the standard deviation. So how do you find those using a probability distribution? And you're going to see some similarities to what we've done before, but you're also going to see some differences because these are not just your standard data points, right? So these are probability distributions, so they're a little bit different. Now, the mean of a discrete random variable is given by the following formula. That is, each value of x is multiplied by its probability, and then the products are added. So just to kind of clarify this formula, you're doing x times the probability first, then we're adding all those up afterwards, okay? There's no dividing here like a regular mean or average, because when we're using probabilities, it sort of already has that division piece built in, right? Because we've divided by the total already to get the probabilities. So that's why you're not doing any additional dividing here. So I'm just going to set up a little table. So I have my x's and I have my p of x. Now I know it's here. I tend to like my tables to go vertical as a personal preference. They don't have to, but I find it a little bit easier to work with. So I'm going to set that up. And my probabilities are 0.16, 0.22, 0.28, 0.20, and 0.14. And what you're going to do here is the first thing you're going to do is multiply these values together, right? So we're going to take our x's and multiply by the probabilities. So I get 0.16, 0.44, 0.84, 0.80, and 0.70. So what I've done is the inside step so far. I took my x's, multiplied by my probabilities, and now I'm going to go ahead and add these up. And when I add these up, I get 2.94. And we can round this if we want to 2.9. Now, when we round, again, follow the directions for your assignment or for that particular problem if it asks you to round a specific way. Like I've said before, usually we round to one decimal place more than what we start with. So here, the values for our x are whole numbers, so that's why we're rounding to one decimal place. But again, always defer to whatever the problem is asking you to do. So here's our mean. So remember, hopefully this looks familiar to you. This is the probability distribution from example 2, where people were rated as passive or aggressive. So it looks like, the mean is a 2.9. So it looks like most people are kind of pretty close to that neutral, or that average is pretty close to that neutral right of 3. So remember, 3 was not passive and not aggressive. So not quite there, but very close to that middle. So slightly less than that 3. Okay, so we can also find the variance and standard deviation using these tables. And again, you have some similarities, some differences. So you saw this idea, same notation, right? Those sigmas here. Sigma squared used for variance, sigma used for standard deviation. So you're still having that square root idea with the standard deviation. And notice that you're still doing the subtracting with the mean and the squaring. So again, you have some similarities here. But what you're going to do as well is you're going to multiply by those probabilities here, just like you did with the means. So you have that extra kind of piece. This actually reminds me a lot of what we did with groups data and what we did with our frequency tables already. So we have that slight change here, making sure to incorporate that probability. And again, we're leaving out the dividing piece in this case because your probabilities already have this division already built into it. So we don't have to worry about the dividing here. All right, so I'm gonna do the same thing. Let's make a table. So I have 1, 2, 3, 4, 5 for my data points. And my P of X is 0.16, 0.22. I'm just kind of rewriting this just so I have it. And again, I like to work vertically, personally, instead of horizontally. All right, so we're not going to start by multiplying anything yet. So I'm going to start with a regular standard deviation step. And I'm actually going to change the color just so we can kind of see the work. So your first step, just like it was before, is to take that x and minus the mean. Now, we already have the mean because we calculated it in the previous example up here, this 2.94. I'm going to use the full version of the mean, not the rounded version. So remember, when you're doing your calculations by hand, use as many decimal places as you can, and then round at the end. So my x value here is 1. So I'm going to do 1 minus 2.94. Then I have 2 minus 2.94, 3 minus 2.94, 4 minus 2.94, and 5 minus 2.94. So you saw that same kind of first step that we're used to. Alrighty, so let's see, I get negative 1.94, negative 0.94, 0.06, 1.06, and 2.06. Now, just like before, we're going to take that value and we're going to square it. So you're still doing that squaring. So each of these values here, I'm going to go ahead and square, etc. Same thing here. And let's see, what I get is 3.7636, 0.8836, 0.0036, 1.1236, and then 4.2436. Now, here's where your next step is going to change a little bit. So at this point now, we're going to go ahead and multiply by our probability. So by these probabilities here. We're going to multiply by the 0.16, by the 0.22, by the 0.20. What was next? By the, by the 0.28, apologize, by the 0.20, and then by the 0.14. And when you get those values, I'm running out of room here, so I'm just going to write them below. You would do each of these values. And what I'm going to get is, I get 0.602176 for the first one, 0.194392 for the second one, 0.001008, 0.224720, and 0.594104. Finally, once I'm done all of that, now I can go ahead and add them. Right, so remember, this is going right in here. So when I add these all up, I get about 1.6164, and using one decimal place, about 1.6. Now, this calculation here is our variance. So our variance is about 1.6. And then to find the standard deviation, we're just going to take the square root of that. Now, when I take my square root, I'm going to use more decimal places again, right? So I want to use more decimal places until the end, and I get about 1.3 if I round to one decimal place. So most of the data values differ from the mean by no more than 1.3. So that's our one standard deviation. Here is that 1.3. Okay. All right, so we have one more topic here in this section, and that is expected value. Now, the expected value is actually the same thing as the mean. The mean of a random variable represents what you would expect to happen over thousands of trials. It's also called the expected value. So if you hear expected value, it is the same exact thing as the mean. So here's the formula. Sometimes we'll use E of X for expected value, but it's the same calculation we've already done for the mean. Just a couple things here to keep in mind. In most applications, applications, an expected value of 0 does have practical interpretation. So for instance, in games of chance, an expected value of 0 implies that a game is fair, which is an unlikely occurrence. Like a lot of times in games of chance, we end up having negative expected values. We end up expecting to lose money. In a profit and loss analysis, an expected value of 0 represents a break-even point. So there are ways that we can get zeros where they actually do have meaning. So you just want to keep that in mind. And although probabilities can never be negative, expected value can be negative. So that's something to keep in mind. And again, we tend to see that a lot with games of chance, or if there's a chance that we're going to lose money. So you can have negative outcomes with things. It's just that your probability can't be negative. So there's two different ideas there. All right, so let's look at an example. So at a raffle, 1,500 tickets are sold at $2 each for 4 prizes. So there's a $500 prize, a $250 prize, $150 prize, and $75 prize. You buy 1 ticket and you want to find the expected value and interpret its meaning. Okay, so the first thing we have to think about here are what are our possible outcomes? Well, you could win, so you bought 1 ticket. You could win the 500, you could win the 250, you could win the 150, you could win the 75, or you could lose, right? So those are the 5 things that could happen. Now, I'm going to set up our table as gains and then probability. So instead of focusing on the winnings, a lot of times we do this with games of chance. We focus on how much money you actually make. So remember, you've paid $2 for a ticket here. So that's one thing you really want to keep in mind here. It's not always about the winning. You have to typically incorporate what you've already spent. So really, this is more like a profit idea than just a winning or a revenue idea. So first thing that can happen is you could win the 500. But remember, you already spent $2 on a ticket, so you're actually bringing home $498 instead. You could win the 250, and again, you spent $2 on a ticket, so you would actually bring home $248 in profit or gains. For the 150, same idea. You've already spent $2, so you're looking at $148 for a profit here. And then for the 75, once you subtract those $2, you have $73 for a profit. Now, the other thing that can happen is that you lose, right? So if you lose, then you actually have we would say it as a negative gain. So you're down $2. So we use a negative to represent loss here. Now, think about the chance of somebody winning, right? There are 1,500 tickets sold. Probability is always part out of total. So there's only one $500 winner, right? So there's one chance to win, and there are 1,500 total chances. So you have a 1 out of 1,500 shot. For the $250 prize, again, there's one chance to win out of 1,500 tickets. For the $150 prize, there's also one chance to win. And then for the $73 prize, there's one chance to win. Now, so there are 1, 2, 3, 4 chances to win altogether. So that means 4 of the 1,500 tickets are going to be winners. That means everything else is going to be a loser. So that 1,500 minus 4 is going to leave you with 1,496 losing tickets. So 1,496 chances to lose, right? Kind of puts it into perspective where you're like, oh, but there's so many chances to win. Yes, there's 4 chances to win, but there's 1,496 chances to lose. So this is the probability for that last one there. So now to find the mean or the expected value, we're going to take each of these and multiply by its probability. So if you want to set up a table, you can do that, or you can just do the multiplication out. So I'm going to take that 498 and I multiply by 1 over 1,500. I take that 248 and I multiply by 1 over 1,500. I take that 148, I multiply by 1 over 1,500. I take that 73, I multiply by 1 over 1,500, and I take that -2, I multiply by 1496 over 1,500. And remember when we did means, after we multiplied everything out in our table, we added it all up. So I'm going to go ahead and multiply these out, and I'm going to add them up here. All right, so saving us some time, I did this on the calculator already, and we get negative $1.35. So our expected value here, or our mean, same thing, is negative $1.35. So what does this mean? Well, if your expected value is negative dollars, that means you should expect to lose, right? So basically what this says is that you can expect to lose an average of $1.35 for each ticket you purchase. So that's what that interpretation is. But really, if you see a negative value for your expected value, you should expect to lose, right? So you shouldn't expect that you're actually going to win this raffle. More cases than not that you're going to lose.